In a trapezoid, we know that the bases are parallel. And since this is not isosceles, the only other information we know is that consecutive angles between the bases are supplementary. So consecutive means in a row. So angles in a row between the bases. Everything else on the trapezoid slide should have been deleted or left where it was because we couldn't label anything else. So this is a trapezoid. For isosceles trapezoid, we still have those parallel bases. The isosceles part means that the legs are congruent. We also know that base angles are congruent. So this is one set of base angles. And then this would be our second set of base angles. Consecutive angles between the bases are still supplementary. And lastly, the diagonals are congruent. Kites have two sets of consecutive congruent sides. So these two sides are congruent, and these two sides are congruent. Non-vertex angles are also congruent. So Q and S are considered the vertex angles, so that makes T and R the non-vertex angles. The diagonal that connects the vertex angles is a perpendicular bisector of the other. So this diagonal cuts the other diagonal in half and forms 90-degree angles. That diagonal also bisects the vertex angles. So these two angles are congruent, and these two angles are congruent. In a parallelogram, opposite sides are parallel and congruent. Opposite angles are also congruent. So Y is congruent to W, and X is congruent to Z. Consecutive angles are all supplementary. So W and Z will add up to be 180. Z and Y will add up to be 180. X and Y will add up to be 180. And W and X will also add up to be 180. The diagonals are perpendicular, so they form 90-degree angle. They also bisect each other. So this is congruent to this, and this part of the diagonal is congruent to this part of the diagonal. In a rectangle, opposite sides are parallel. They're also congruent. Rectangles have 4 90-degree angles. And they have congruent diagonals that bisect each other. Consecutive angles are technically still supplementary, even if it's not labeled. Opposite angles are also congruent. In a rhombus, all four sides are congruent. Opposite sides are parallel. The diagonals are congruent, and they're also perpendicular bisectors of each other. So each diagonal is the same length, and they create right angles. Opposite angles are congruent, and the diagonals bisect those angles. So we know that angle M is congruent to angle T, but also that they are bisected. So each portion of M is congruent to each portion of T. The same thing happens with H and A. Lastly, we have a square. All four sides of a square are congruent, and opposite sides are still parallel. The diagonals are congruent and are also perpendicular bisectors of each other. So each portion of each diagonal is congruent, and they create 90-degree angles. A square has four right angles, so each angle, T, A, P, and E, are all 90 degrees. The diagonals bisect those angles, forming 45-degree angles at each portion of the corners.